Hey everyone, I'm Anil, and in this video, we're going to explore visually the difference between RAG or retrieval augmented generation and agents, right? So let's start actually with one step lower, which is an LLM, right? And let's look at an example that we'll carry through this, video, which is, let's say we want to build an app that, we can ask or chat with about the weather. So it's, an LLM powered weather planner. So we ask it a query, what is the weather like in Mumbai next week? Now we're not typing this into ChatGPT. We are using an LLM, we're trying to build an app. So we're going to be using an API, right? So if you type this into ChatGPT, what you will get will be slightly different from what you see here. So let's say we ask this question and you're just sending it to the LLM. Now the LLM is basically a neural network, right? A very complicated, large neural network that is designed and trained on a ton of data that allows us. And so as a result, the parameters of the neural network, which are the weights of the neural network, are set, right? Based on the data it's trained on to give you a response. And because these neural networks are large, the latest, GPT models, for example, are now in trillions of parameters. And so they are exceptionally accurate at predicting the next set of words. So assuming that this neural network has been trained on the data that contains weather reports as well, it can give you different kinds of answers. Now in this case, because we're saying next week, the neural network has been trained well enough. In our case, I queried GPT, the latest GPT 4.0 mini, right? And what it tells you is, well, it can't give you real-time weather information, right? Because it does not have access to forecasts, right? It's just an LLM. And so based on its weights, but it's also been trained well enough to respond with something like this when it does not have an answer. What if you give it a slightly different question? Let's say, what's the weather generally like in Mumbai? Now, it's probably been trained on past data, right? Depending on when the last training, iteration was. Let's say it was last year that it had access, or it was trained on data from latest last year. It's able to give you an answer, something like this: Mumbai experiences a tropical climate, so on and so forth. So somewhere in its training data, it has seen information about weather in Mumbai. Now, we don't know if this is accurate though, right? It's just the LLM giving you an answer, basically based on your prompt, predicting the next set of words. And this is based on its weights. So the problem here is when you ask it a question, like when you ask it to write a fictional story, it's just going to generate a story, right? And it's fictional, so it's fine. When you ask it a factual question, it gives you an answer sometimes. Sometimes, if it does not have information and is well trained, tells you it does not have information. But this is a more general question. It gives you an answer that might sound right, right? It is humid, tropical, hot and dry season, has a monsoon season. It's quite general. Now, there's more information to this. And so it is not very bad, but it's based on past data. It can't give you exact information. That is where retrieval augmented generation comes in. Now, before we apply this to weather, let's look at a slightly more general example or more widely, seen example. So let's say I'm asking information about NVIDIA's, revenue, for example, for the latest. I'm not given the time frame, but let's say it's for the last quarter, right? Now, how is it going to get access to this? So in a typical retrieval augmented generation, you just ask the LLM this question and it has no context, it has no information. It can probably give you, based on the data it's trained on, it might generate an answer that is kind of based on previous numbers it has seen. They might be accurate, they might not be accurate. However, if you type this query into ChatGPT, for example, it would do something similar to this. In this case, or in typical RAG, what you'd do is you'd have a document store where, let's say, all the annual reports have been broken into chunks, vectorized, and stored. And this is a vector store. In this case, this query would be routed to the vector store. The relevant chunks of information would be retrieved. Then this query and the relevant chunks would be sent to the LLM. So now the LLM is using the retrieved information augmented with the query, and then it's going to give you an answer. NVIDIA's revenue is so and so, it has a year-on-year growth. Now, when you type this into the latest ChatGPT versions, right, what you're going to see is it's going to call the web, right? So it's going to do a web search. And so effectively, technically, you could call that a tool call because it's searching the web. But if you think of the web as an archive of information, it's effectively getting you the relevant documents and giving you an answer, right? It's technically more like an LLM workflow, but the basic idea is it's retrieving information, augmenting your query with that. So your LLM now has information or actual information. The LLM is basically extracting the relevant chunks and giving you a sensible answer. And that is the right way to use an LLM, right? It's a language model. When you want it to explain things to you, it understands your query, but then you need to give it relevant information. Now, in the case of our weather information, it's an interesting example because you ask LLM the query. Now, in this case, what we do is ask the LLM to extract the location and the dates, and then you have a weather database, let's say, which has forecast information for the next 2 weeks, right? If you look at weather APIs, they can give you information for the next 2 or 3 weeks. And it would look something like this: what the day is, you would have a date here as well, you would have the temperatures, you would have humidity, and so on. So what you're doing is based on the query, if you can extract the location and dates without an LLM, that's fine. I'm just using the LLM as a processor here. But effectively, you're going into a database and retrieving the relevant data. You're now passing that to your actual LLM query. So this query plus this retrieved information, and now your LLM is giving you a more interesting forecast. So in this case, now I've queried GPT-4o Mini again, but now I've given it access to this, and it's not one query. I've given it access to the entire week's information like this. And these numbers are made up, right? Don't hold me on that. But they're not very bad either. They're fairly sensible for Mumbai. And based on that, the LLM is giving you an answer like, it's seeing a minimum of 25 and a maximum of 35. That's purely based on this data point. But, if you give it more information for the week, it'll tell you that, and so on and so forth. So it's now actually acting on information that you've provided it. And so this is also not a bad example of RAG, right? Ideally, in practice, when people talk of retrieval augmented generation, they typically mean documents in a vector store. But even if you extract information from a database, supplement that with your query, and the LLM is able to get an answer, it qualifies as RAG. These are examples of LLM workflows, right? Where the idea is the workflow is set by the developer, right? So you're telling it how the queries need to be routed. You're telling it first go to the LLM and extract the location and the date. And so the query to the LLM would be the first, function here. The LLM's prompt would be extract the information from, the prompt or the query. Then you're telling it go to a vector database, or in this case, a weather database, and get the relevant information. You could add a tool call. So let's say you have access to a more sophisticated weather tool that, apart from this, does some other computing, right? So that again is, you're predefining it. You're telling it that this is the workflow it has to follow. And then you're telling it, now after this, go to the LLM and give me the answer. And I've written more advanced metrics because there's a tool here, but it could be the same answer as the previous one. So the idea with LLM workflows is, and RAG is an example of that, where you are telling or predefining as a developer what the flow of data and control is in this app, right? The LLM basically is a function that's being called to do something. You're telling it exactly what you want it to do, extract the date and city, let's say. And in this case, based on the information, give you a summary of the forecast. The next evolution in this is when it becomes an agent. So how is it different? Well, the components of the agent are the same if it's an LLM agent. So in this case, same query, you have an LLM, but now it's an agentic system. So what we've done, or an AI agent, not a system, it's an AI agent. So what you do with the AI agent is, or an LLM agent is, you give it a system prompt that explains to it what it's expected to do. The system prompt is like the developer prompt now in modern, for example, in GPT, the OpenAI API, more recently, you can call it the developer prompt. What it's doing is giving the LLM instructions, and you're telling the LLM that it's an agent or an assistant. You're also telling it that based on the tools provided, it needs to figure out and answer the query. And what the system then understands it has to do is it understands it has to plan, and it has access to tools, and it can call those tools. So in this case, we've given it the weather tool and the weather database, which is exactly what we had previously. Previously, we had set up the flow. We had said, actually, I'm going to call the LLM. It's going to give me some information. It's going to call the tool. It's going to call the database, and so on. In this case, I've given the task to the LLM, which is, what the weather will be like. But in this case, it's not the LLM. It's the agent. And the agent has got a role, or it's been assigned what its job is. In this case, it's a weather assistant. It's got supposed to use the tools and based on the query, give you an answer on what the weather is like. So the LLM in this agent is now going to call the weather database, you know, extract from that. It would have already figured out that it has to extract the date and the location. It's going to go here and query this to get these dates. If it knows how to use the weather tool, it's going to then query the weather tool. So depending on how you instruct it, it is supposed to understand what it's supposed to do. But then you're not telling it which tool to call and when. It figures out it has to call this tool. It figures out it has to call the weather tool. It figures out how to use the information based on the system prompt you've given it. And then it gives you that answer. Right. And so the difference between a predefined workflow and an agent is that in the agent, and I'm talking LLM agents here, the LLM in this case is given the query, it's given, you have to write the system prompt well enough, and then the LLM decides which tool to call. It decides when to call those tools. It decides what its plan is and how it will get the relevant answer. So you need to explain to it what answer you want. And it's up to the LLM to figure out how to use these tools to give you that answer, right? So you've told it it's a weather forecasting, and it's a very simple prompt. Ideally, you'd write a more complicated prompt that explains what it's supposed to do and what format you want the answer, and the LLM then does the tool calls. And so that is an LLM agent. And when people talk of agentic systems now, what you're having is workflows where you have multiple agents working with each other. And some of these flows are predefined, meaning you set those flows, but there are some flows that are defined by the agent. So you have not just one agent, you could have multiple agents, right, doing different things. Let's say you're doing a travel planning. You could have an agent that handles the weather part of it. You could have an agent that handles the booking. You could have an agent that handles the payment part. And then these agents work together, right, in a predefined manner based on your workflow. Or in some case, you could have an agent that orchestrates or manages, so a manager agent that handles this whole process and gives you the relevant answer. So in that case, in a booking example, which we will cover at some point, just as a practice example, you'll see how, given the query, the agent is designed and it is able to figure out it has to do these things, sub-allocate those tasks to individual sub-agents, do the job and get back to you. So hopefully this has given you an understanding of how we've gone from a simple LLM call to a full-fledged agent. When you use tools online like ChatGPT, they're somewhere in between workflows and agents, where in some cases they're predefined, or rather they pre-programmed or preset to call, say, web search for certain scenarios. In some cases, tools are becoming agentic, right? Copilots, even a tool like ChatGPT, when you ask it, to analyze an annual report, it's kind of figuring out what to do to search the web, to call a Python script, and so on, and give you the answer, right? And so it's important to understand the earlier versions of, say, ChatGPT were purely an LLM call, right? Whereas now what you're seeing is more in the line of workflows and agents. And understanding the difference is key when you're building systems. So hopefully this has helped you understand, what these pieces of the puzzle are. And then as we go along in the series, we will build more agents. So hopefully this has helped. See you in the next one.